All right, picture this. You're an astronomer, it's late, you're staring at your screen, and then boom, a little smudge of light shows up where there was nothing just moments before. And it's moving fast, like impossibly fast. Its path isn't a gentle curve around our sun. Nope, it's a straight shot just slicing through our solar system from the deep, dark void between the stars. This isn't just another asteroid. This is a visitor from a whole other solar system. And, whenever a stranger this weird shows up, there's really only one question on everyone's mind. What is it? Are we looking at a random frozen chunk of cosmic debris, basically a giant snowball flung from a distant star? Or could it be something a little more deliberate? An alien probe, maybe, sent to take a peek at our little corner of the galaxy? That right there, that's the big mystery we're gonna unravel today. So first, let's get properly introduced to our main character. Its official name is 3I/Atlas, and that 3I is important because it's only the third interstellar object humanity has ever spotted, an uninvited, and let me tell you, a very, very unexpected guest. And the moment it was spotted, it kicked off an absolute sprint. After the first sighting on July 1st, 2025, we pointed everything we had at it. The Hubble, the James Webb, you name it. Everyone was scrambling to get a look because they were literally racing against the clock. By the end of October, it was going to whip right past the sun and just vanish back into the darkness forever. To really get why everyone was so hyped, you just need to look at this number. 210,000 kilometers per hour. That's how fast it's moving compared to our sun. It's going so ridiculously fast that our sun's gravity is basically a speed bump, not a net. There was no way we were ever going to capture it. It was just passing through. That incredible speed, that's the smoking gun that proves it's not from around here. And because it's only the third one we've ever seen, scientists have this really cool name for it, a messenger from afar. I mean, think about it. Every rock, planet, and comet in our solar system, they were all born from the exact same cloud of gas and dust. But this thing, it was born somewhere else, around a totally different star. It's carrying the chemical fingerprints of its home system, which gives us this precious, one-of-a-kind sample of a different neighborhood in the galaxy. But of course, a weird rock isn't exactly the most exciting theory on the table, is it? Some scientists looked at the early data and saw something else entirely. So now, let's dive into the really controversial part, the case for this thing being a piece of alien technology. The main guy pushing this idea is Harvard astrophysicist Avi Loeb. He's got a bit of a history of suggesting these interstellar visitors might be artificial. He and his team took a look at all the initial data and basically threw down the gauntlet with this question in a research paper, arguing that 3I/Atlas was showing some seriously weird anomalous behavior. And Loeb's team didn't just point to one odd thing, they laid out a whole list, 7 anomalies. First, it was huge. It had this bizarre jet that was pointing forward, not trailing behind like a normal comet tail. Its chemistry seemed all wrong. It was spitting out nickel, but none of the iron you'd expect to see with it. And the way light bounced off it, a property called polarization, hinted at a complex, maybe even metallic surface. But the real smoking gun for them was its path. It was so perfectly lined up with our planets that the odds of that happening by chance were less than 1 in 20,000. Yeah, that improbable trajectory is really key here. The object's path wasn't just some random flyby. No, it brought it incredibly close to Mars, Venus, and Jupiter. The argument was, look, this seems less like a cosmic pinball bouncing around and more like a planned tour of our solar system. The odds were just way, way too slim for it to be a coincidence. And just to give you a sense of the sheer power we're dealing with here, let's talk energy. Based on its size and that insane speed, the kinetic energy of this thing is equivalent to 667 million Hiroshima bombs. Now, let's be super clear, it poses absolutely zero threat to Earth, but that number just highlights the incredible power these interstellar objects are carrying. It's why we really, really need to pay attention to them. Okay, so that was the case for the prosecution, and it sounds pretty compelling, right? A powerful object on a path that seems almost deliberate? But in science, for every extraordinary claim, you need extraordinary evidence. So let's pivot and hear from the defense. Let's look at how the wider scientific community explains all these weird anomalies. This is the case for it being simply a comet. A very, very weird comet, but a comet nonetheless. Okay, let's start with that bizarre anti-tail. The claim was it looks like some kind of propulsion system. But the evidence from our best telescopes, it tells a very different story. What's happening is the sun is heating up one side of the comet's core, causing ice to turn directly into gas and kick up a bunch of dust. This creates a plume that points towards the sun, which from our angle looks like it's pointing forward. We've actually seen this before on other comets, so not propulsion, it's just sunshine hitting a big dusty snowball. All right, what about the weird chemistry? The claim was that spitting out nickel without any iron just isn't natural. But as scientists got more and better data, the picture got a lot clearer. The Very Large Telescope detected not just nickel, but also cyanide gas. And guess what? Both of those things are commonly found in the comas of comets right here in our own solar system. So yeah, the ratios might be a little different, but the ingredients themselves are perfectly normal for a comet. And that brings us to a really important idea, the coma. The coma is just that fuzzy atmosphere of gas and dust that forms around a comet when it gets close to the sun. It's this activity, this outgassing, that's the source of all the features that looked so strange at first. It's the engine that's driving those plumes and releasing those chemicals for our telescopes to see. And this right here is the piece of the puzzle that makes it all click into place. The James Webb Telescope found that 3I/Atlas had this really bizarre chemical recipe. For every 1 part water ice, it had 8 parts carbon dioxide ice. You know, dry ice. That is a huge amount. And here's the key. Dry ice turns into gas way more easily and much farther away from the sun than regular water ice does. So that high dry ice content, it explains everything. It explains why 3I/Atlas started glowing and showing activity so much earlier than a normal comet would. Its strangeness wasn't technology. It was just a unique recipe. So it's not an alien probe. It's just a very, very weird snowball from a star system that's probably super rich in carbon dioxide. So if it's not aliens, why should we care? Does this just get filed away as another boring rock story? No way. Absolutely not. The debate around 3I/8LAS and what the whole thing represents is actually incredibly important for the future of astronomy. This entire episode, the wild claim, the controversy, the frantic rush for more data, and then the eventual scientific consensus. This is a perfect example of science working exactly the way it's supposed to. It's a process. You question things, you propose different ideas, from the totally normal to the completely extraordinary, and then you test them against cold, hard evidence. Controversy isn't a sign that science is broken. It's a sign that it's alive and pushing at the edges of what we know. And here's how scientists actually separate the strange from the truly unexplained. You can think of this chart as a map of weirdness. It plots objects by their size against any acceleration that isn't caused by gravity, basically any little push they get from things like outgassing. You could see all our local comets and asteroids are kind of clumped together. The second interstellar visitor, Borisov, fits right in there. ʻOumuamua, the first one, is way out on its own, a true anomaly. But our visitor, 3I/Atlas, all the data puts it right in the middle of the normal comet zone. It's exotic for sure, but it still plays by the rules. When you look back, the story of 3I/ATLAS is just a perfect textbook case of the scientific method in action. Step 1, you see something you can't explain. Step 2, you come up with a bunch of ideas, some wild, some normal. Step 3, and this is the crucial one, you gather more data with better tools. And finally, step 4, that new data lets you test your ideas until the evidence all points to a clear conclusion. So, the verdict is in. 3I/Atlas was a natural messenger from another star, a strange and wonderful piece of a distant solar system. But the story is far from over. With new observatories coming online soon, we're about to start finding these interstellar visitors not once every few years, but maybe several times a year. So the question we're left with is this. We know what this one was, but what will the next one be?